Have you ever stopped to wonder, could we be the last technologically advanced civilization Earth will ever see? It sounds like the plot of a sci-fi movie, but what if it's not? What if the society we've built, with all its brilliance and complexity, is a one-time miracle, never to be repeated? Today we live in a world powered by planes that soar across the sky, cars that carry us over vast distances, robotic arms that build other machines, computers that process trillions of operations per second, and spacecraft that fly far beyond our own atmosphere. Humanity, now nearly 8 billion strong, has risen to become the planet's dominant force. But we didn't arrive here easily and certainly not for free. Our technological climb was fueled by massive amounts of natural resources, billions of tons of coal, oil, and natural gas. These substances didn't magically appear overnight. They are the result of millions of years of pressure and heat deep within the Earth, transforming ancient biomass into the fuels we burn today. And crucially, these resources are not infinite. Once used, they take millions of years to regenerate, far beyond the scale of any human civilization. Which raises a chilling question. Was this industrial leap a one-time opportunity? If humanity were to vanish, whether through nuclear war, pandemic, or another unforeseen cataclysm, would the Earth ever again give rise to a species capable of achieving what we have? Could another civilization start over and reach the stars? That's the unsettling thought we're going to dive into today. I'm Alex McColgan, and this is the Astron Podcast. In this episode, we're taking a long, hard look at the rise of human technological society, what it took to build it, what resources it consumed, and whether those vital ingredients would still be around if someone had to start from scratch. It's a grim thought experiment, but let's go there together. Imagine the end of the world, today. Boom. In a single devastating moment, civilization as we know it is wiped out. Perhaps it's nuclear war. Perhaps a gamma-ray burst. Maybe a runaway AI or a global environmental collapse. Whatever the cause, all modern technology is gone. No power grids, no computers, no books, and definitely no internet. Cities crumble. Knowledge is lost. The survivors, whoever they are, find themselves hurled back into the Stone Age with nothing but the natural world and their own wits. But to make this a fair test, let's assume nature itself is left unharmed. The forests remain standing. The oceans still teem with life. The minerals beneath the earth are untouched. The only thing gone is the infrastructure and information we built. Nothing can be salvaged, no machines, no buildings, no remnants of the old world. Like an ultimate survival game, everything must be rebuilt from the ground up. The first challenge? Survival. The remaining humans will need three things right away: food, clothing, and shelter. Luckily, these essentials are still accessible through renewable resources. Trees can be chopped for wood. Animals and crops can be hunted, gathered, or farmed. Wool and cotton can be harvested and woven into clothing. Even without high-tech tools, these basics are achievable using primitive techniques. Sharp sticks can be turned into hunting spears. Stones tied to branches with rope or hemp become axes and knives. With nothing but wood, stone, and fire, humans can scrape together the fundamentals needed to stay alive. From this base, a hunter-gatherer society could re-emerge relatively quickly. People could live in huts, cook food over fire, clothe themselves with hand-woven fabrics. It wouldn't be easy, but it's certainly possible. In fact, it's been done before, thousands of years ago. Our ancestors made it work, and with time, our future survivors likely could too. But the real question is whether they could go further. Could they reach the level we're at now? Could they move beyond sticks and stones, toward machines, computers, even space travel? To get there, they'd need to develop metalworking, starting with bronze and iron. Bronze, a mixture of copper and tin, was the first major leap. It marked the transition from the Stone Age to something more advanced. Melting down copper and tin ore requires heat, roughly 230 degrees Celsius for tin and just under 1,100 degrees Celsius for copper. These temperatures can be achieved using wood-based bonfires, especially if carefully managed. That means bronze, while not easy, is within reach for a determined civilization. With bronze, they could make better tools, weapons, and even basic mechanical parts. But iron is where things get complicated. Iron is far more abundant in the Earth's crust than copper or tin, but its melting point is much higher, around 1,583 degrees Celsius. That's well beyond the reach of an ordinary bonfire. To extract usable iron, you need to reach those extreme temperatures, which ancient humans did only after inventing new techniques like the use of kilns, air blowers, and eventually charcoal. Charcoal is key. Made by burning wood in low-oxygen environments, charcoal burns hotter than regular wood because the water and volatile substances have already been removed. This hotter burn makes it possible, barely, to smelt iron. Some ancient furnaces reached up to 1,500 degrees Celsius using charcoal, enough to extract and shape iron on a limited scale. But there's a catch: it takes a lot of wood to make charcoal. Vast forests must be cut, and they must be replenished regularly. This demands both space and time. Worse yet, land used for forestry can't be used for farming. A growing civilization needs both. That's why, historically, societies transitioned to fossil fuels. Coal, oil, and natural gas allowed for much higher temperatures much more cheaply. Coal in particular became the fuel of choice for steel making. It burns hotter, lasts longer, and doesn't require nearly as much land as wood-based fuels. Without fossil fuels, the steel industry as we know it could never have developed. And without steel, our modern world would not exist. Now you might be thinking, why not just scale back? What if the new civilization remained small, moved slowly, and used only sustainable materials? Could they still reach the stars just on a longer timeline? It's a noble idea, but unfortunately the answer is probably no. The absence of fossil fuels wouldn't just slow them down, it could stop them entirely. That's because fossil fuels are not just about energy. They're also used in manufacturing some of the most critical materials of the modern age. Start with steel. Today the world produces nearly 1.8 billion tons of steel per year. It's used in everything from buildings and bridges to cars and spacecraft. And producing steel on that scale requires intense heat that only fossil fuels can reliably deliver without devouring vast amounts of land for charcoal. But that's only the beginning. Next, consider concrete. It might not seem as glamorous as steel or electronics, but concrete is the foundation, literally, of modern civilization. Roads, runways, skyscrapers, dams, all built on concrete. To make cement, the binding ingredient in concrete, you need to heat limestone and clay to around 400 degrees C. Again, this demands high temperatures, and in large quantities. Fossil fuels make this possible. Without them, constructing concrete at an industrial scale becomes nearly impossible. Then there's plastic. One of the most versatile materials ever invented, plastic is made almost entirely from petroleum. No fossil fuels? No plastic. That means no pipes, no packaging, no wires, no synthetic fabrics, and no insulation. Every phone, computer, and electrical device relies on plastics in one form or another. Without plastic, large-scale manufacturing becomes a logistical nightmare. Another big one? Ammonia. It might not sound exciting, but ammonia-based fertilizers are the backbone of modern agriculture. Without them, our food production would plummet. Ammonia is created using the Haber-Bosch process, which consumes natural gas to produce hydrogen. This reaction, vital for growing crops at scale, would be extraordinarily difficult to recreate without fossil fuels. No ammonia, no mass agriculture. No mass agriculture, no population growth. The new civilization might survive, but thrive? Not likely. And finally we come to silicon. No, not the beach stuff, refined silicon, the element behind all modern electronics. It's found in abundance in sand, but purifying it for use in microchips requires temperatures of over 350 degrees C. That's well beyond what even charcoal can produce. To make the smartphones, computers, and satellites we rely on today, you need incredibly precise manufacturing processes. Processes that only became possible because of fossil fuels and the industrial infrastructure they powered. So even if our hypothetical civilization managed to claw its way back to iron tools and rudimentary farming, it would face massive barriers to advancing further. Without fossil fuels, producing the materials for high-tech development becomes a monumental challenge. Could they eventually develop alternatives? Maybe. Could they harness renewable energy sources like wind or solar to power high-heat processes? In theory, yes, but in practice, even that transition requires fossil fuel infrastructure to build and maintain. And that leads us back to our central question. If our civilization were wiped out today, could the next one ever reach the stars? Based on what we know, it seems unlikely. Fossil fuels gave us a unique boost, a one-time surge of cheap, powerful energy that allowed us to leapfrog from hand tools to space stations in just a few centuries. That window might not open again. The next civilization might have the will. It might have the brains. But it might not have the fuel. That realization should give us pause. Because it means that what we have now, this extraordinary era of satellites, space telescopes, artificial intelligence, and interplanetary exploration, might not be repeatable. We could be the first and the last. And if we don't take care of what we've built, if we let it collapse, we might be closing the door forever on humanity's shot at the stars. The past few decades have often been called the Silicon Age, and it's easy to understand why. From phones and laptops to satellites and spacecraft, silicon-based computer chips are the backbone of modern technology. Try to picture a world without computer chips. It's nearly impossible, especially when it comes to space travel. The precise calculations needed to guide a rocket into orbit and beyond depend heavily on computers. These computers, in turn, rely on silicon chips to function. Without them, launching a rocket becomes an exercise in frustration, guesswork, and failure. And chips aren't the only thing we rely on. Think about the materials we use every day. Many of them require incredibly high temperatures to process. Temperatures that are difficult to achieve without burning something. That something is usually fossil fuels. Whether it's smelting metal or refining chemicals, fossil fuels are the engine behind much of our industrial power. They're not just energy sources. They're ingredients in everything we build, wear, and even eat. Our entire modern lifestyle is balanced on the availability of fossil fuels in ways most people don't often consider, even though we see the consequences around us all the time. Plastic is one of the clearest examples of this. Sure, we often criticize the overuse of plastic, especially when it comes to pollution. But when it comes to functionality, nothing beats plastic's versatility. It's durable, lightweight, and easy to mold into almost any shape. From the keys on your keyboard to the sterile tubes used in hospitals, plastic is absolutely everywhere. Even in places you wouldn't expect. It's inside car bumpers, medical equipment, clothing, packaging, food containers, and perhaps most ironically, even inside the technologies we use to create clean energy. Yes, even wind turbines depend on fossil fuels. A typical wind turbine is about 70% steel and 10% plastic. Steel production requires massive amounts of heat, usually generated by burning fossil fuels like coal or natural gas. And plastic, as we've established, comes straight from fossil fuel sources like petroleum. So even when we're trying to move toward renewable energy, the journey is still paved with fossil fuel footprints. The irony is both impressive and sobering. Without the energy and materials made possible by fossil fuels, building renewable systems would be much harder, maybe even impossible with today's methods. Nowhere is this more evident than in space exploration. Rockets are extremely weight-sensitive. Every additional kilogram of weight demands extra fuel to lift it into orbit. This is why lightweight materials like plastic are essential in the aerospace industry. Engineers use it wherever possible to reduce weight without sacrificing strength. From insulation to structural components, plastic helps keep things light, efficient, and cost-effective. Without it, rockets would be bulkier and less efficient, making space launches more expensive and potentially less frequent. In short, plastics, and by extension fossil fuels, are quietly propelling us into space. Then there's ammonia. You might not immediately link ammonia to space travel, but its importance to humanity is enormous. Ammonia is primarily used in fertilizer, which is what makes modern agriculture so productive. Without ammonia-based fertilizers, it's estimated that around half of the current global population wouldn't have enough food to survive. That's not an exaggeration, it's a harsh reality. While natural fertilizers exist, they just don't deliver the same yield as industrially produced ones. And ammonia, crucial to this process, is made from methane, a natural gas derived directly from fossil fuels. So, when we talk about fossil fuels, we're not just talking about powering cars or factories. We're talking about feeding people, building cities, saving lives, and yes, reaching space. These fuels are woven into the very fabric of our civilization. This creates a challenge when we imagine a future where fossil fuels no longer exist or are significantly depleted. It also raises an interesting question. If another intelligent civilization were to rise after us, long after we're gone, could they achieve the same level of technology without fossil fuels? Let's try to answer that question by first considering how much fossil fuel we've actually used. Finding a perfect estimate is tricky. But we do know that as of now, humanity consumes around 15 billion metric tons of fossil fuels every year. That includes oil, coal, and natural gas. And that number keeps rising as populations grow and economies expand. If we take this annual usage and work backward to the Industrial Revolution, which began around the 1800s, we can form a rough estimate. We multiply the usage by the number of years, then adjust for the fact that consumption was much lower in earlier decades. Doing this rough math brings us to an estimated total of around 750 billion metric tons of fossil fuels consumed since the beginning of the industrial era. That staggering amount of fuel was what it took for us to get to where we are now, technologically advanced, digitally connected, and even beginning to explore space regularly. But how much is left? That's the next piece of the puzzle. And this is where things start to get a bit more concerning, especially if you're imagining the future of humanity, or another intelligent species, trying to repeat our path. According to current data, the world's proven reserves of fossil fuels will last us for only a few more decades. Oil and natural gas are expected to start running out within the next 50 years, possibly sooner if our consumption continues to increase. Coal will stick around a little longer, with estimates suggesting about 130 years of supply remaining. But even that timeline could shrink depending on global demand. Using the same ballpark estimate, the amount of fossil fuel we have left is roughly equivalent to what we've already burned, around another 750 billion metric tons. At first glance, that might seem hopeful. If we've got as much fuel left as we've already used, then a new civilization would, in theory, have the same resources we had. But here's the catch. Most of the easy-to-reach fossil fuels are already gone. The low-hanging fruit, the surface deposits, the shallow wells, they've all been tapped. What remains is buried much deeper underground. Getting to it requires highly specialized machinery, technology, and energy, ironically, much of it powered by fossil fuels. This means a future civilization would face much steeper challenges in starting from scratch. Back in the 1950s, the average oil well was drilled to a depth of about 1.1 kilometers. Today, that average is closer to 1.8 kilometers. And in some regions, companies are drilling as deep as 9 kilometers to reach viable oil and gas reserves. That kind of depth isn't just hard to reach. It's almost impossible without advanced equipment. A future society trying to rebuild from a post-collapse world would likely lack the infrastructure to dig that deep. They'd need to develop tools, generate energy, and build machines, all without the fossil fuels that made those things possible in the first place. And yet, it's not entirely hopeless. The resources, though harder to access, are still technically there. A determined, intelligent civilization could find creative ways to extract and use what remains. They might even invent new technologies that surpass our current systems. Instead of relying on oil rigs and coal mines, they might focus on harnessing methane from biological sources. Methane can be extracted from composting organic waste or from certain types of bacteria. It can also be synthesized under specific chemical conditions. And yes, methane is a viable rocket fuel already used in some modern spacecraft. In that sense, a future society could eventually develop spaceflight again, even without the same abundance of fossil fuels that we once enjoyed. But their journey would be very different from ours. It would likely be slower, more experimental, and more reliant on sustainable practices. Their technology might evolve in unexpected directions. Their materials could be organic or bioengineered rather than synthetic. Their energy sources might include geothermal, solar, or even nuclear fission and fusion, assuming they can develop or rediscover the knowledge required to use them safely and effectively. Of course, this civilization's population would probably look different too. Without the food production made possible by ammonia-based fertilizers, it's likely their numbers would be much smaller. This could mean fewer people to build infrastructure, develop innovations, and drive scientific progress. But smaller populations might also foster a more sustainable and balanced relationship with their environment. They could be more careful, more deliberate, and perhaps even more respectful of their planet's limits, qualities our own civilization hasn't always embraced. Another factor to consider is necessity itself. Often, it's the urgency of a problem that leads to the most powerful innovations. If a future civilization faces survival-level challenges, they might be more driven to invent new solutions. While the path would be steep, they might adapt faster out of sheer need. It's possible that scarcity could become the mother of invention, just as it has many times in our own history. When forced to rely on alternatives, people tend to find them. And that spirit of problem-solving could be their greatest asset. They may develop new methods for recycling old materials. They might build space vehicles from salvaged metals or use biodegradable polymers that don't depend on fossil fuels at all. Perhaps they'll create entirely new kinds of computers, based on biology or quantum physics. They could even bypass fossil fuels altogether, leaping straight into a clean energy future from the very beginning. Their challenges would be different, yes, but their opportunities could be just as great, if not greater. So, can a future civilization get back to the stars without fossil fuels? The answer is a cautious yes. It would take a different path, a more difficult journey, and likely a lot more time. But it could happen. They wouldn't look like us. Their technology wouldn't resemble ours in many ways. But their ambition, curiosity, and drive could push them forward just as ours did. They would need patience, creativity, and resilience. But where there is will, there is always a way. A different kind of space age could still rise from the ashes of our own.